Hello, Mustangs. I'm glad to be back with you, if just virtually. Um, Hope you all had a great spring break and you're ready to get back into some learning. Um, we have some weird days ahead of us, but we're going to get through it and we're going to learn some geometry. So sit back and enjoy this video. Um, Make sure that you take notes as you go through this video, pause it whenever you need to, jot down any important information. But most importantly, just take your time. Okay, here we go. Okay, so we're going to jump back into finding the area of polygons, and we're talking about specifically about regular polygons today. Um, and so what is a regular polygon? Well, it's a polygon that has all sides congruent and all angle measures are congruent. So let's keep going on. So what is it that we are going to need? Well, there's a couple of definitions that we need to make sure that we have down and understand. First one is called the apothem. Okay, so the apothem is a segment that extends from the center of the polygon and it goes to the midpoint of a side. Okay? And it's also perpendicular to that side. So in both of these figures, that red line, that is the apothem. Okay, starts at the center, goes to the midpoint of a side, and it's perpendicular to that side. Okay. Okay, the second definition is the radius. Okay. A radius is just a segment that extends from the center of the polygon to a vertex, so an angle. Okay, so make sure that you have those down, write them down, rewind if you need to. Okay. All right, so going on, now that we have those two definitions, okay, we have the formula that we're going to use for finding the area of regular polygons. And it's a straightforward formula, and it just goes that the area is equal to 1/2 times the apothem times the perimeter. Okay, very simple formula. It gets a little deep when we're trying to actually find what those pieces are, the apothem and the perimeter. But the formula itself is pretty elegant and short. Okay. All right. So just to recall, perimeter is just the distance around. So if you take one side length and add all of the side lengths up together, that gives you the perimeter of the figure. Okay. So another way that we can write this instead of writing 1/2 times the apothem times the perimeter is to say that the area equals the apothem times the perimeter divided by 2, right? Multiplying by 1/2 is the same thing as dividing by 2. Okay, and then our shortest definition here is just area equals A times P over 2, A standing for apothem, P standing for perimeter. Okay. All right, so let's jump into it. Let's do an example here. Okay, so the example that we're looking at first says find the area of an octagon with an apothem of 6 centimeters and a side length equal to 7 centimeters. Okay, well, an octagon, okay, for your reference, I put the names of some popular polygons off to the side there. So an octagon is an 8-sided figure. Okay. So our formula for area is the apothem times the perimeter divided by 2. Well, the apothem, they tell us, is 6. Easy peasy. The perimeter, they don't give us directly, but we can get it pretty quickly. If the side length is 7 and there are 8 sides, then the entire perimeter is going to be 8 times 7, or 56. Okay. So now that we have our two pieces of information, the apothem and the perimeter, we're going to plug those into our formula. So 6 times 56 divided by 2. And that will give us 168 square centimeters. Now remember, when we put our labels in, when we talk about area, it's always square units. Okay, so centimeters squared in this instance. Okay. Going down to the next slide. Okay. So sometimes we'll find that in problems we won't be given the apothem or the perimeter directly. And in those cases, then we're going to have to use our good old trig functions to find them. Okay, so if you recall from a couple of months ago, okay, our trig functions are sine, cosine, and tangent that we're using. Okay, sine is equal to the opposite leg over the hypotenuse. Cosine is equal to the adjacent leg over the hypotenuse. And tangent is equal to the opposite leg over the adjacent leg. Okay. And I know it's been a while since we've done this, so we're going to go pretty slowly through this just to get you back into the groove. Okay, so first example. Find the area of a hexagon with radius equal to 4 and a side length equal to 4. Okay, so a hexagon, okay, that's a six-sided figure. Okay, so we need our two pieces of information. We need the perimeter and the apothem. Okay, well, the perimeter we can get pretty quickly. Okay, since the side length of the figure is 4 and there are 6 sides, 6 times 4 gives us 24 for the perimeter. The apothem, we're going to have to do a little work. Okay, not a lot, just a little bit. Okay, so we're going to think about it this way. Okay, the sum of the central angles. Okay, so the sum of those 6 central angles is 360. Okay, all the way around, a complete circle, 360. Well, one of those central angles is we're going to get 60 by doing 360 divided by the six central angles. Okay, so we get 60 for one of those central angles. Okay. Well, if we were to go ahead and drop an apothem or draw an apothem into that figure, okay, so that would be the purple line that goes from the center to the midpoint of a side. Okay, it's going to bisect that central angle, and it's going to bisect the side length. Okay, so that's some important information that we're going to use here very shortly. Okay, well, that central angle there, okay, it was 60 degrees, but when we dropped in that apothem, it got bisected. So now we have that 30-degree angle sitting in there. Okay, and it looks like now, since we have an angle measure, and we have at least one of the pieces of our trig function, we can go ahead and use that to find out what the length of that purple segment is, the length of that apothem. Okay. Okay. So if we were to pull out that triangle that we just made by dropping in the apothem, this is what we'd have. Okay? This triangle right here. There's our 30-degree angle. There's our apothem. And this is the radius. Okay? Well, this is a right triangle, okay, because that apothem is perpendicular to the side length. So we have this right triangle, so that means we can use our trig functions. Okay? Well, if we're looking for A, okay, from the perspective of our 30-degree angle, this is the adjacent side, and the 4, that leg right there, that is our hypotenuse. Okay, so if we have adjacent and we have hypotenuse, we're talking cosine here. Okay, so if you recall, we're going to do cosine of 30 degrees is equal to adjacent over hypotenuse. Okay, so cosine of 30 is equal to A over 4. Okay. So when we plug cosine of 30 into our calculator, okay, we'll get a decimal. And then to get A all by itself, we're going to have to multiply both sides of the equal sign by 4. Okay, and that will isolate the A for us, and that will give us A is approximately 3.46. I say approximately because we have to round. So A equals 3.46. So we've got our apothem now. Okay. Alrighty, so it looks like we have both pieces of information that we need now. We have our perimeter, we have our apothem. We can plug those into our formula here. Okay, so our area is going to be 3.46 times 24 divided by 2. Okay, and that's going to give us approximately 41.5 2 units squared. Units squared. All right. All right, so at any point here, if you need to rewind the video and take a quick look at it again, I would urge you to do that. Just make sure that you understand this. Okay, okay. Next challenge. So we're going to use another hexagon again. But this time, what if we aren't given the perimeter? We're not given the apothem either, okay, or apothem. How can we find the area of this hexagon? They're only giving us a radius of 3. Okay. Well, since we're only given the radius, we're going to have to use our trig functions again. Okay. We're gonna have to do it twice. Okay. We're going to have to use our trig functions to find the apothem, and then we're going to have to do it again to get the side length. Okay. All right. So let's dive in here and see how this works. Okay. So again, we have a hexagon. Each of those central angles is going to be 60 degrees. We're going to drop in that purple line, that apothem, draw it in there so that it's perpendicular to a side length. Okay, and again, it's going to be 30 degrees. Okay, when we drop in that apothem, we're going to get a 30-degree angle here. 90 degrees here. Here's our apothem. There is our hypotenuse of this right triangle. Okay. So we're going to do our trig function, and we're going to say cosine of 30 degrees is equal to a over 3. Okay, we're using cosine again because it's adjacent over hypotenuse that we have to work with. Okay, so we'll get an apothem of approximately 2.6. Okay, due to rounding, 2.6. Okay, so we're halfway there. We've got our apothem. Let's see if we can work on getting our perimeter. Okay, well, this time, instead of using our trig function to get the length of the purple segment there, the apothem, we're going to use our trig function to get this section right here, this B that I'm calling. Okay? Because we have this right triangle again here when we drop the apothem in, okay? So we can use our trig functions to find this segment. Okay? So, but instead of cosine this time, we have, from the perspective of the 30-degree angle, we have opposite and we have hypotenuse. Okay, so we're using sine this time. Okay, so we're going to do sine of 30 degrees equals b over 3. Okay, and when we plug that into our calculator and isolate the b, we're going to get that b is equal to 1.5. Okay, so that means if this section right here, our b that we just found is 1.5, the entire side length then is going to be 3. 1.5 and then double it. That gives you 3 for the side length. Okay. So we're almost there. Okay, we needed to get the side length, but we're going to use that so that we can get our perimeter, okay, which is easy enough because if the side length is 3 and we have 6 sides, that means that we're going to multiply 6 times 3, and that's going to give us a perimeter of 18. Okay. Okay, almost there. Last part. We're going to plug our perimeter and our apothem into our formula. Area equals apothem times perimeter divided by 2. Okay, so when you plug that into your calculator, you should get 23.4 square units. Square units. All right. So if you need to go back and review any part of this video, please do. Please do. Don't just gloss over anything. These next couple of weeks are going to be a little hectic. You're going to have to really dig in and figure some things out on your own. But of course, I'll always be there to answer any questions for you. Okay, so this should give you or put you in a good position to be able to handle the homework for tonight, which is a Google form. So happy hunting.